An accurate clock shows 8 o'clock in the morning. Through how many degrees will the hour hand rotate when the clock shows 2 o'clock in the afternoon? So this is the clock showing 8 o'clock in the morning, and in the afternoon it becomes 2 o'clock. So actually this situation becomes like this. Well, by just looking at it, you can tell that the difference, that is the hour hand, has rotated by 180 degrees, isn't it? So actually option D is the correct answer, but let's solve this problem traditionally as we would solve other problems. So how many hours have passed by since 8 o'clock in the morning? Well, 1, 2, 3, 4, 5 and 6 hours have passed by. So we need to calculate how much does an hour hand move when it travels 6 hours. Okay, so in 12 hours the hour hand rotates by 360 degrees, right? So in 6 hours how much will it rotate? Okay, so x times 12 is equals to 360 times 6, right? 6 times 2 is 12, so x is equals to 360 by 2, and that's 180 degrees. So option D is the correct answer. What is the angle between the minute hand and the hour hand of a clock when the time is 4:20? Well, many people will mark the answer as 0 degrees because they would think that both the hour hand and the minute hand point to 4, but that is not the case. While this minute hand moves for 20 minutes, the hour hand also gets pushed forward. So approximately this will be the position of the hour hand, and we'll have to calculate this angle. So what will be theta? Well, theta will be the angle subtended by the hour hand minus the angle subtended by the minute hand, isn't it? So let them be x and y. So x minus y will give you theta. Well, before we go ahead, let us convert this 420 into hours. So 420 is actually 4 plus 20 by 60 hours, right? 20 minutes can be written as 20 by 60, and 20 times 3 is 60. So 3 4s are 12 plus 1, that's 13. So 13 by 3 hours. This is the number of hours. Now for hour hand, in 12 hours the angle subtended or the angle traced is 360 degrees, right? So what will be the angle traced in 13 by 3 hours, right? So x is equals to 360 times 13 by 3 divided by 12. Okay, 12 times 30 is 360 and 3 times 10 is 30. So 130 is x, right? Now let's calculate for the minute hand. So in 60 minutes the angle traced is 360 degrees for a minute hand. So what will be the angle traced in how many minutes are there? Well, there are 20 minutes, isn't it? So in 20 minutes what will be the angle traced? So y is equal to 360 by 60 times 20, right? So this cancels out. 6 times 6 is 36 and 20 times 6 is 120. So y is 120. So this is theta is equals to 130 minus 120, and that's 10 degrees. Right, so option B is the correct answer. At what angle the hands of a clock are inclined at 15 minutes past 5? So this will be the position of the hands at 15 minutes past 5. Let us calculate the angle subtended by the hour hand, and then we'll calculate the angle subtended by the minute hand, and then we'll take the difference, and that will be the angle of the hands. Well, let us first calculate how much is 15 minutes past 5. So 15 minutes past 5 can be written as 5 hours plus 15 by 60, isn't it? And 15 times 4 is 60. So 5 times 4 is 20 plus 1 is 21. So this is 21 by 4 hours. Now let's calculate the angle traced by the hour hand. So in 12 hours the angle traced is 360 degrees. So what will be the angle traced when it travels or when it covers 21 by 4 hours. So 21 by 4 hours. Right. So x is equal to 360 times 21 by 4 divided by 12. Okay, 12 times 30 is 360, and 2 times 15 is 30, and 2 times 2 is 4. So 15 times 21 by 2, and that is, if you calculate it, 157.5 degrees. So this is the angle subtended by the hour hand. What will be the angle subtended by the minute hand? Well, there's no need to calculate it. You can tell it just by looking at it. Well, it is, let's say this is the relative position. This is the position where it started. What is the angle traced when it travels 15 minutes? Well, a right angle. So y will be equals to 90 degrees, isn't it? So we need theta. So theta is equals to angle subtended or angle traced by the hour hand minus angle traced by the minute hand. So that's 157.5 minus 90, right? And that is equals to 67.5 degrees. And 67.5 is actually 67 1 by 2 degrees. So option C is the correct answer. How many times in a day are the hands of a clock in a straight line but in opposite directions? So this is our clock. For simplicity purposes, let us take the time duration as 12 hours, right? From 6 a.m. to 6 p.m. right? We need to calculate the situation for one day, but we'll first calculate it for 12 hours, then multiply it by 2, right? That becomes simple for us. So from 6 a.m. to 6 p.m. Well, at 6 a.m. the hands will be in a straight line and opposite in direction, right? So this is the first time they came in a straight line and in opposite direction. Now every hour it happens once, isn't it? And the last position will be at 6 p.m. and the position of the hands will be the same as it was at 6 a.m. right? So how many hours have passed by? Well, 12 hours have passed by. And how many times did the two hands come in a straight line and in opposite directions? Well, it happened 12 times. But we'll need to consider it as 11. Why? Because the position at 6 a.m. and 6 p.m. was same, right? So we basically counted the same position twice. One at 6 a.m. and one at 6 p.m. So we need to subtract one from them. We need to count it as only single, right? So for 12 hours, this condition or this phenomena where the two hands come in a straight line but in opposite direction happens 11 times, right? So one day consists of 24 hours. So in 24 hours, it will happen 11 times 2, that is 22 times, right? I hope you got the point. So option B is the correct answer.